just yet, so I'll think about that. So that's where we are. Emily, I just talked about the final. You may want to get the information from someone. So let's get started then. And we'll go section by section by section. And then when I am in the section, I will tell you a little bit more on where you should focus. So section 8.4. There are two main ideas to focus on in section 8.4, and the two problems that I talked about that will be from this section. One will be on mass, and the other problem will be on center of mass. And specifically, so there will be one problem on one dimension, right? Say, either finding the mass or center of mass, one dimension. And then there will be one problem on two dimension, finding out the mass or center of mass. I believe I'd assigned problems like 21 and 31, and I had done 26 in class, I believe. Analysis and earlier problem I may have done or assigned number 9. So those are the kinds of problems you want to focus on. What I can tell you is the problems that I have selected for the final are problems that are either from your homework or problems that I've done in class. So you focus on those two things and you'll be totally fine in the final. In section 8.5, as I said, there's only one problem in this section, and it's a problem on work done. And remember, work is force times displacement. In class, we looked at problems like number 12, and then I believe I had assigned number 13. And problems like number 22. How much work is done in removing water from a tank type of thing. From 8.6, as I indicated earlier, go ahead if you want to work out the homework problems from 8.6 that I was assigned, fine. But for the test problem, focus on consumer surplus and producer surplus. be one problem asking you specifically, giving you consumer surplus, asking you to find the consumer and producer surplus. So in preparation for the final, focus on that. In preparation to do the homework, you have the other problems, present value problem, future value problem, that kind of stuff. From section 8.8, focus on a problem. Okay, so, but let me back up. So in section 8.8, we talked about mean and median and probability density function and so on and so forth. Focus on finding the median. Okay, so that is where your focus needs to be. There, again, as I said, there's going to be one problem from 8.8, and while, again, the homework problems involve many of these other ideas, mean, PDF, probability density function, median, and so on. The issue that for you would be, what is the median, and how do you use that definition to find the median given some distribution, right? So what is the median? The median is the value or the line that divides a data set into two parts, right? The lower 50 percentile and the upper 50 percentile. Or if you're talking about a region, it's the point which divides the region into two equal halves. So the median is a value, it's a number. And that's what you want to focus on. And from 9.1, I haven't really decided on what it's going to be, but think about problems like, I did 48 in class, I've assigned 49. So there's that group, 47 through 49. And then I've also, I believe I may have done number 58. And I've assigned 57 and 59. Think about 59, that could be something that I may, so 47 through 49 and possibly 58, 59. 58 I've done in class, should be part of your notes, and then 59 I've assigned for homework. So that's your final. Plus, as I said earlier, 5 problems from the midterm. Very similar, if not identical. 5 problems for the midterm. Total 11 problems. I haven't decided on whether I'll add an extra credit. Again, the final exam is not finalized as yet. If I decide to add the extra credit, I will do it at the end, but I'm not sure at this point. So, with that in mind, some of you walked in, so let me make sure you get your exam back. And so this is homework. So it's homework plus, it may just be homework. I've also returned the group work to you. So if you don't see it, check with your partner. And what did I do there? Kristen?
Yeah.
Please take your exam. Kim? Yeah, welcome. Art? Susan?
Thank you.
Welcome. Kelly? Is it easy? All right. And all right, so let me go back to 8.4, and let's do some problems. So when you look at a problem like number 13 or 31, right, they have the same figure. The only difference is that in 13 you have a variable density. The density is variable. In 31, the density is constant. The other thing is that in 13, you're simply being asked to find the mass, and in 31, you're being asked to find the center of mass. Now, mind you, mass is simply density times area, right? If the density is constant, then it's simply the constant value multiplied by the area of the region. So it's a very simple proposition. Density, mass is density times area. If the density is a variable density, then you integrate by taking rectangular strips, that kind of stuff. So for a problem like number 13, because it's a variable density function, because the density is a variable function and not a constant, in this case, you would have to integrate. In number 31, on the other hand, the density is constant, right? So this density is simply a multiplier and nothing more. But what is, how do you find the center of mass? Well, the center of mass is moment arm, right, times the mass. Moment arm times the mass. Now, if you have a region like the triangular region there, what you would have to do is split it into smaller slices, rectangular slices, and then find. So let's look at 31. Go ahead, everybody read. Since the density is constant, right? It says uniform density. We can find the mass very easily. Let me make the picture first. Somebody please confirm if these are correct. Yes? Okay, thanks. So what is the area of this region? Area is 1/2 base. Now mind you, the total length of the base is b over 2 plus b over 2, which is b. And the height is a, so this is 1/2 ab. As simple as that. Don't have to integrate, don't have to do anything. And the mass will be the density, rho, times 1/2 AB. So this is 1/2 rho AB. Now, in order to find the center of mass, we will divide the mass times the moment arm over the total mass. We already have the total mass. All we have to do is find the mass times the moment arm. So let's take a rectangular slice. What is the length of the rectangular slice? If I multiply the length by the moment arm, which in this case is x, then it'll give me the moment about the y-axis. So take 30 seconds, discuss with your neighbor how you will find the area of this rectangular region. I'll give you a hint. Equation of the line, right? So take a second. Find the equation of those two lines. See what you get. That's the slope of that line. The equation of the line, y minus 0 equals slope x minus a. So y equals negative b over 2a times x. Let's call that y1. This is
plus b over 2.
Negative b over 2ax plus, you know what?
It should just be plus b over 2.
Plus b over 2. Oh, I should have left it as b over 2a times a minus x, but that's okay. So let's look at this line. For this line, is b over 2 all over A, or simply B over 2A. So y2 is B over 2A times x minus A. Everybody good so far? So the question is, what is this total length? It'll be the sum of y1 plus y2. Now you've got to be a little careful. Look at y1, look at y2. If you were to add, okay, so let's rewrite this as b over 2ax minus b over 2. If you were to add y1 and y2, what would you end up with in the current state? 0. But clearly you know y1 and y2, the sum of the two cannot be 0. What's going on here? Well, y2, think about y2. It's all below the x-axis, right? So it should be y1 minus, remember, y2 is below. So it's minus a minus. That's what gives you the additive property. So the total height here, or length, will be this minus this. So negative b over 2ax plus b over 2 minus negative b minus b over 2ax minus b over 2, which will give us 2 times, if you add these two, it'll be 2 times negative b over 2ax plus b over 2, or the 2's will cancel out, and we get, am I good so far?
Mm-hmm.
And we get negative b over ax plus b. So the area of this region, delta A, is negative b over ax plus b times delta x. And the moment will be equal to rho times the integral from 0 to a of x times negative b over ax plus b dx. Now, please note, because of symmetry, what can we say about y bar? Y bar will be 0. X bar will be some value in this direction. So let's compute this. We can pull out a b here, correct? That'll make it a little easier. So let me bring this up here. Moment equals rho times b times the integral from 0 to a of 1 over ax squared plus x dx.
Should be negative, probably.
Negative. And so this gives us rho v times x cubed negative x cubed over 3a plus x squared over 2 from 0 to a. At the upper limit, this will give us a cubed over 3a will give us a squared over 3. And here it'll give us plus a squared over 2. And at the lower limit, it'll be 0 everywhere. And this gives us what? Negative 1/3 plus 1/2 is 1/6. So this gives us a squared rho b divided by 6. We're just about there, folks. X bar equals the moment, the total moment, divided by total mass. Everybody comfortable with that? The total moment is a squared rho b over 6. Total mass is rho ab over 2. And this will give us what? The 6 will come down, the 2 will go up. The rho will cancel out, the b will cancel out, and we'll get a over 3. X bar is a over 3, y bar is 0.
Saying y bar equals 0, like, it's sufficient to just say that because of symmetry it would x.
Yeah. Note that I didn't do anything with y bar, just use
Right.
symmetry. Correct. That should be your focus, or types of problems like that. Number 13 is a little easier than that. I'd also done number 26 in class. Note that 26 is a one-dimensional problem, right? I talked about 2 problems from this section, one involving 1 dimension and one involving 2 dimension. This is an example of a 2-dimensional problem, and then there will be one problem on 1 dimension. Folks, for those of you who walked in a little late, I have to get out of here by 11. I have a nephew's graduation, and it's out where you teach, out in the boondocks. I call it boondocks. So I got to find my way out there. I generally don't go that far.
Where's it at?
I I don't even know. But I know it's kind of way, way, way somewhere. And I know some of you come far distant to get to the ball, so. And it's at 1 o'clock, so. Let's go to 8.5. How long will it take? You know, I got to go home, change. How long does it take? An hour and a half, 2 hours, something like that?
Depends on where you're going.
Yeah, we don't know where you're going.
You know, traffic is always horrific whenever I've gone out west.
Yeah.
I don't know.
That's
I'll find out.
Do you know what's really not helpful? No.
We've already asked that. No.
Yeah.
Graduated, we're happy.
Yes.
So do you go home and your wife tells you where you're going? How are you going to get there?
No, I call my brother.
Oh, okay.
Well, text him right now, see where it's at. We'll help you out.
I could have done all of this yesterday, right?
True. Right.
My life is just on the run. So it's like, I just didn't want to be late to the place. That's why.
So what you're saying is you might have to get out of here at 10:30 if you're trying to follow Susan's advice.
What is it?
Oh, no,
Are you scaring me?
No, I always, when I'm going somewhere new, I have a horrible sense of direction, like even with the GPS. I give myself a half an hour to get lost, or if there's a car accident, or that magic half an hour that I'll sit in water.
I give myself negative 15 minutes. It's not a good plan.
I get the extra half hour whenever I'm flying. I hate flying. I absolutely hate flying. So I'll get there 2 hours before the flight. Oh yeah. Oh yeah. Right. I just flew in from Houston earlier this week, and yeah, the flight was at 9 o'clock. I was there at 7. Light again.
Man, I only get there that early for international, but that's because of cost.
Well, I don't like flying, so the last thing I want to do is be rushing to the gate and then getting in the plane. So let's go to 8.5.